Hello everyone, I am Dr.C.Kiranmayi, Area Chair and Assistant Professor, Digital Transformation and Operations, Department of Management Studies, School of Business, Aditya University. In this present lecture, I am going to discuss about Simplex method, the key terminologies of Simplex method and also how to set up the starting Simplex table. Simplex method is used to find the optimum solution for the linear programming problem, which involves more than two variables, whereas graphical method can be used to find optimum solution for the linear programming problem, which involves only two variables. But in practice, in general, linear programming problems may have more than two variables up to n variables. So, in order to solve such kind of linear programming problems which involves more than two variables, we have Simplex method, and Simplex method is called an iterative algorithm. Since in Simplex method we find solutions in step-by-step procedure. That is, in first iteration we will obtain one solution, and moving to the next adjacent the initial solution will be improved. So, in order to obtain the best possible solution, which is called optimum solution. So, that is why this Simplex method is called an iterative method. Okay. And the iterations are continued till the optimum solution is reached. So, coming to the key terminologies of Simplex method. So, the first one, standard form. So, initially the linear programming problem will be in the form of either maximization or minimization model and subject to constraints, and all the constraints are going to be inequalities or equalities, that is, which are in the form of less than or equal to, or greater than or equal to, or equal to, or sometimes the linear programming problems may also have mixed constraints. Okay. So, this given problem we have to transform into standard form. So, what is standard form? So, whenever we are going to solve the linear programming problem using Simplex method, the given problem should be transformed into standard form. First, we have to observe whether the given problem is in either maximization model or minimization model. If it is in maximization model, nothing to be done. But if the problem is in minimization model, it should be converted into maximization model by multiplying the given objective function with minus. So, this is how first we have to look at the objective function, whether it is in maximization or minimization model. If it is not in maximization, we have to convert into minimization by multiplying the minimization objective function with minus. And after that, all the constraints are to be converted into, all the constraints which are in the form of inequalities are to be converted into equalities. Suppose if the constraint is less than type, we introduce slack variables. So, for which slack variables are introduced? For less than type of constraints, we introduce slack variables. For greater than or equal to type of constraints, we introduce surplus variables in order to convert the inequalities of the constraints into equations. And artificial variables also sometimes we use when the inequality is of equal to type, which is an equation. So, we initially transform the given linear programming problem into standard form, that is, converting, if the problem is in minimization model, convert into maximization model and convert all the inequalities into equations by introducing slack, surplus and artificial variables. And we have another, often we use another term, basic variables. So what are basic variables? What are non-basic variables? Which variables we call as basic variables? If we substitute the to obtain the solution, initially we substitute x1, x2, 0 in the objective function. So when we substitute x1, x2 with zeros, we obtain initial solution for the variables. So the variables which has non-zero solution initially, so such variables are called, the variables with non-zero values at the corner point are called basic variables. And non-basic variables, the variables which have zeros at the corner point. So initially, to find the basic feasible solution, we substitute x1, x2, 0 to obtain the value of the variables s1, s2, s3. So if the values of these slack or surplus or artificial variables is going to be non-zero, these variables are called basic variables, and the value of the variables x1, x2 is going to be 0 at the corner points. These variables are called non-basic variables. So these are the terms which we use. And table. So initially, in order to find the optimum solution, the given linear programming problem should be transformed or should be set up in the form of a matrix which represents the matrix. So that in order to set up the table. And pivot operations. So in order to improve the solution, to identify the key row and key column and to pivot element, we do apply basic matrix operations, row operations, which we call, those are called pivot operations. And also we use another term, basic feasible solution. Basic feasible solution. Initial basic feasible solution is a solution which satisfies all the constraints and including the non-negative constraint. The initial solution obtained by substituting x1, x2s as zeros is called the initial basic feasible solution. Initial basic feasible solution, which is called IBFS. And now, so this initial basic feasible solution is to be checked whether it is optimum solution or not. For that, we have to perform row operations and we should identify the key element, and then the respective calculations are done to check whether this initial basic feasible solution is optimum solution or not. And we also use another term, feasible region. Feasible region is that region which satisfies all the constraints. So all possible solutions, set of all possible solutions. So we know that in the previous lecture we came to understand that a linear programming problem may have unique solutions or multiple alternative solutions. But among the multiple alternative solution, which is the best alternative solution, and that best alternative solution we call it as optimum solution, and the set of all possible solutions satisfying the constraints are called feasible region. So these are the basic terminologies which we use in simplex method. And here we are with a linear programming problem which is in maximization model, and we are given constraints which are all less than type of constraints we are given in the problem, and non-negative constraints are also we are given. And so we have to solve this problem using simplex method. So the first step of simplex method, first we have to look at the objective function. Look at the objective function, whether it is in maximization model or minimization model. It is in maximization model. Therefore, nothing to be done with this objective function. And look at the constraints. So, if all the constraints are less than type of constraints, regular simplex method we can use to find out the optimum solution. But if any one of the inequality is of greater than type or equal to type, then we have to use big M method or two-phase method to find the optimum solution. But here in this problem, all the constraints are less than type of constraints. So, in the first step in simplex method is transforming the given LPP into standard form. So, that is take back all the variables on the right side to the left side, convert the objective function into equation. Okay. So, Z if we take all the variables from the right side to the left side, these become plus will become minus, therefore Z minus 13x1 minus 11x2 is 0. This is the objective function. And since all the constraints are less than type of constraints, we have to use slack variables. That is, we have to add slack variable. Remember, slack variables are to be added to less than type. For less than type of inequalities, we introduce slack variables which we add to the inequalities in order to transform them into equations. So, the first one is 4x1 plus 5x2 less than or equal to 1500. So, therefore, 4x1 plus 5x2 plus s1. So, since the first inequality is less than type, so I have added the first slack variable to the first inequality in order to transform that into equation. And since already I have introduced first slack variable in the second equation, second equation is also less than type, therefore another slack variable S2 I have added to the second inequality to make it as equation. Likewise for the third inequality. So, this is how first we have to transform the linear programming problem into standard form, and all those slack variables which we have introduced should also be shown in the non-negative constraints. And next thing, so after transforming the standard given linear programming problem into standard form, the next step is to find IBFS, that is initial basic feasible solution, to find the basic variables and non-basic variables. So, to find out the initial basic feasible solution, we substitute the variables x1 and x2 with 0. Therefore, if we substitute x1, x2 0 initially, so x1 0, x2 0, s1 is 1500 and s2 is 1575, s3 is going to be 420. So, this is how first we have to find out the initial basic feasible solution, and also these variables are to be shown in the objective function also, like z minus 13x1 minus 11x2 plus 0 s1 plus 0 s2 is equal to 0. Okay. And so, when we substitute x1, x2 with 0, the values of s1, s2, s3 is 0 and z value is going to be, objective function value is going to be 0. Therefore, while understanding the key terms of simplex method, we understood that all those variables whose values are non-zeros are called basic variables. All those variables whose values are zeros at the corner point are called are called non-basic variables. Okay, therefore S1, S2, S3, these are having non-zero values at the corner point. Therefore, these are called basic variables, and x1, x2 are zeros. These are called non-basic variables. So, this is how first we have to find out the initial basic feasible solution. Now, the next step is to set up the starting simplex table. So, this is how the simplex table looks, and the first column represents row numbers, and the second column represents the basic variables. Basic variables are those variables whose values are non-zeros. So, here the basic variables are S1, S2, S3, and remember all those basic variables are to be shown here. So, and Z is the, and we have to set up the coefficient matrix. Already we have I have explained that the simplex table means the linear programming problem, the standard form of the problem should be represented in the form of a matrix. Okay, so Z. So initially first we have to write the values of the objective function, and how many variables are there in the given problem? There are only two variables. Those two variables x1, x2 should be shown, and we have introduced three slack variables S1, S2, S3. So, the value of S1 in the first equation, first row represents first equation, second row represents second equation, third row represents third equation. So, in the first equation, the coefficients of S1 is 1, the coefficient of S1 is 1, X2 is 5, X1 is 4. All those are to be introduced here, 4, 5, 1, and the coefficient of Z in the first equation, there is no Z, therefore, the value of Z is going to be 0, and there are no S2, S3 in the first constraint, therefore, we write their coefficients as 0. And for S2, in the second equation, in the second inequality, the coefficient of x1 is 5, coefficient of x2 is 3, S2 is 1. So, x1 is 5, x2 is 3, there is no S1 in the first inequality, therefore, it is 0, S2 is there and its coefficient is 1, and there is no S3 in the second constraint, therefore, its value is 0. And likewise, we have to enter all those values of S3 from the third constraint for the third row. And after writing these values, the last but one column is going to be the solution column. So, initially we have found the IBFS. So, S1 is 1575, S3 is 420, S1 is 1500. Those values we have to represent here, and the initial value of the objective function is 0. So, that is also we have to represent in the starting simplex table, and the value of Z initially, the second row, this row represents the values of the variables in the objective function. So, in the objective function, Z value is 1, okay. So, x1 coefficient is minus 13, x2 coefficient is minus 11, s1, s2s are not there in the objective function, their coefficients are going to be 0 because they are the slack variables represents the unused resources. That is why their coefficients are going to be zeros. So, this is how we have to set up the starting table, and this is the last column is called minimum ratio column, minimum ratio. So, how to find this minimum ratio xb by xk? So, first to find out the minimum ratio, first we have to find out the key column and key row. Key, how we observe the key column. First we have to identify the key column. So the most negative value in the among the coefficients of the objective function. So among these values, which is the most negative? Minus 13 is most negative. So first we have to determine the key column by observing these coefficients of the objective function, and the most negative is minus 13. Therefore, this column is going to be the key column. This is going to be the key column. And after identifying the key column, the next step is to identify the key row. So how do I identify the key row? That is, the formula is xb by xk. So xb is the these values, the solution values, xk, this is xb, and xk is the key column. So respective values. So first value is 1500 and the respective value in the key column is 4. That is 1500 by 4. 1500 by 4. That is 375. Likewise, for the second value also we have to find the minimum ratio. 1575 by the respective value in the key column is 5. So 1575 by 5. It is 315. And likewise for 420, the value in the key column is 1. That is 420 by 1. That is 420. So this is how we have to find the minimum ratio. So after finding the minimum ratio, then we have to identify the key row. So key row is that row, the term itself suggesting minimum ratio. Key row is that ratio which has minimum ratio. Among these values, 315 is minimum. Therefore, this is going to be the minimum key. This is going to be the key row and this is the key column. So this is how we have to identify first key column and followed by key row, and then the intersection of key column and key row is 5, which is called pivot element, or key element. So this is how first we have to determine the key element, and then we have to proceed to the next iteration using this key element. We have to find out this IBFS is of optimum solution or not. We have to perform the net evaluations and then we have to check whether this solution is going to be IBFS or not. Otherwise, we have to move to the next iteration using this key element. So, by the end of this lecture, we came to understand when to use simplex method, what is simplex method, and the basic concepts of simplex method, and how to transform the given LPP into standard form, and how to set up the starting simplex table. So these are the concepts of this present lecture. Thank you.